Okay, so here's our project, Parking in Macau, and we have 3 team members, Qin Yang, Wilson Tai, and me, Ma Mingyang. So at first, I want to talk about traffic. When it comes to traffic, people generally think of the dynamic sense of cars running on the road, but urban traffic is more than that. Every car will have a long stopping state, and the combination of stopping and starting is the essence of traffic. As the urbanization continues to accelerate, car ownership has been showing rapid growth. By the end of 2021, there have been more than 80 cities in China with a million car ownership. When there are so many cars in the urban space, people have to face the problem of where to park the car. And Macau's land area is small and the corresponding parking area is also small. In some popular areas, the number of parking spaces in the area is not enough to accommodate the large number of cars that come in during the popular hours. As the parking difficulties cause a certain degree of traffic congestion, while parking plans are also affected by traffic congestion, which creates a vicious circle. And nowadays, the website of Macau Transport updates the data of parking space in each parking lot in real time. However, we found 2 obvious problems. First, when users use the interface, they usually only care about the information of 1 or 2 parking lots, but you can see here they have many of and we don't need all of them. In addition, this table only shows the data at a certain moment in time, and one cannot get any trend information and thus cannot tell whether the number of remaining parking spaces is certainly increasing or decreasing. This shows that there is still a lot of room for improvement in parking management in Macau. So next, I want to show you some international parking experience. In Singapore, the government developed a public parking application called Parking SG in 2017, which allows drivers to select parking spaces and parking duration online on their phone. And in Japan, almost all parking lots have parking guidance, real-time information, and self-services payment. And finally, in USA, they use robots in the parking lot to move cars parked in designated areas of parking lot to the space, which saves people's time in parking. And in our project, we will further optimize the visualization of parking data and combine it with data from other platforms to provide more beneficial information to Macau residents. At the same time, we'll analyze the existing data to explore the deeper information of different parking lots. Finally, we'll use the model and existing data to predict the future parking data. These efforts will have a great impact on solving the problem of parking difficulties in Macau. Once the parking problem is solved, it will not only relieve the parking pressure of residents, but also allow the parking management companies to reduce the cost, relieve the sorry. Oh, oh. Uh, okay. And help the city planning department to make informed decisions. Therefore, we believe that solving the parking problem in Macau is of great value. And next, welcome my partner Wilson to show you the visualization part.
Hello everyone, my name is Wilson. In this part, I'm going to talk about the visualization of our project and how do we make the data transform visually. So first, we design this website or this design the visualization part. We want to make a website that is easy to look and to make parking we want to make the parking information become more simple and give more further informations like history records or live or of the whole parking situations or and assess them to make the parking decisions. Just like if you go to that very popular area and you want to know where is the peak hour of there or how many space left on that part, we want to provide this solution to our users. So first thing first, actually there's a lot of parking informations on Macau in Macau, and for the official website we can find that the DSAT, the Transport Bureau of Macau SAR, actually they have made their own real-time informations on public car park. It is convenience for the citizen to check about to check their target parking lots, how many space are left on there. There is always live informations of here because they will update in 5 seconds, so there is very detailed. And as you can see here, they will always update number on there. But if you can see the hyphen, that means they're not provided. The parking lot is not provide this type of this type, just like the just like this parking lot is not provide a motorcycle space. But as you can see that there's a lot of parking lots here, but it is not sorting by area or name or any other things. It's sorting unorganized, so we don't think that is a very nice design to find your target parking lots in a very short time. So we want to decide a website that can provide can uh, can have this advantage, that can display the target public car park live information and history records, and easy to know where the popular area is. And if you have to wait about the space because their parking lot is very popular, so we can recommend you near car park information for the alternative efforts. But disadvantage is because of all this data is come from the official websites. So we if the official website doesn't provide any informations of the of that car park, so we will not gain any information of it. So that's the but yeah, we have only one source of this parking information, uh, so we think that is a very big disadvantage of it. So for our web design, we have made by four major components. One uh one of them is the trend chart, heat map, drop down list, and the recommendation table. These four major components make our website become more easy to find out where's the parking information to find out the parking information. So I would talk about detailedly for these four components, what the function of it. So first, I want to introduce about the trend chart first. And in this trend chart, we have created five different channels of here. The port present trends or space at every parking lot. In this section, tracking table is organized by five subports. Each of them represent different space of their catalogs, which is cars, motor, electricity, electricity car, electricity model, and disability person's car. This support will display space changing of every catalog around 24 hours. They can provide history data for our users to estimate space and schedule daily plan. Besides, the port uh, update time is 5 seconds, just like the official website. And the next one is well, the next part is the drop down list because there are 64 parking lots in Macau, which means it's not proper to display all information in single page. If we do that, that is make us no difference between the official and our own website. So first, this drop-down list is designed for selecting which parking lots the users are interested. Then tracking table and the recommendation table will update to the select parking lots to let them know or let them load their which parking lots they are interested or they want to know precisely. And the next part is we want to have the parking conditions about Macau. So we provide a heat map to we provide a heat map for a full picture of Macau SAR with text of public parking lots. The color marks are designed to help user quickly know which parking lots is available for parking. When users move the mouse to any other text, the informations about their parking lots will pop up, including name, location, space, and coordinate. And also, we create this heat map by two tools. One is called Portly and the Mapbox. These two tools for of visualization is very amazing for us to do this. And also we have a color scale on here, and it is very easy for our users to know about an amount of space by this a range of color. And just you guys know, the Macau Islands is always become have so many yellow points out there, but Taipei, Cotai is not very usual to see the yellow color. For the last component, we create a recommendation table. Every city has the same traffic problem. There's popular area. With more people on the same area, the possibility of traffic jam or no space left will be higher. To solve this problem, you can not only show how many spaces left in every car part. Guiding them to other nearest car part seems to be a solution. Therefore, recommendation table is built for finding other available car part if the one you are looking for is full. It proposes an alternative way for making a ride fast, comfort travel experience instead of waiting a long time for a space. And for the recommendation table, we have provided the top three results of it because we have considered that if we provide the rest of it is useless and is not unsuitable for every user situation, because if we provide the rest of it, that is not that is not proper for them in that target area because they were far from it. So we have provided this top three result. We have top three result is the shortest time, the shorter distance. But how do we calculate the distance and the time of every locations? We have to find the way to do this very easy so that we have used the road API from AMAP, that's the golden map. Uh, we use this API to help us to calculate every single car part is, and it will give us about the distance and the time results of it, and we have shorting by the nearest time, but the shortest time and the shortest distance. And the users can use the drop-down list to select which car parks they are interested, and they when they select of it, we will show it. We will update the trend chart and the recommendation table for them to know about the informations and also the drop-down list, and also where they can park their car park easily. So for the car park locations, we will actually, how do we get the latitude and the longitude? We have go to the Macau data centers to take the official API about the Macau public car park info. So how can we get all of the car park locations? We just want the latitude, and longitude, and so that we have to go to the official website to get an official API about the Macau public car park informations. And on this XML file, we have get the coordinate about the 64 public car parks, and we will use to powerful powerful visualization tools, that is Mapbox and Golden Map, for to create our components, which is heat map and the recommendation table. And now I'm going to show you how our website is working in the wheel operation. The main frame of or the main tools in this visualization project is that the very powerful tools is called Potly. And Potly is it can provide some operation kits with a less code, and this website this website design or these four components also is made by the Poly and is the very main functions, main library for us to make it to be possible. So that as we have run the Python file, and you can see that this is our visualization project, and I will show you in the real operations about how to we get our target informations to know the space. Let's see. So this is our website of it, and here you can see there's our trend chart, our drop-down list, heat map, and recommendation table. And here I can show you how we make how we operate this website to find our target or for our target car parks which we are interested. So let's see. In the drop down list, and you can see we can scroll down and find one of the target car parks. Let's see. Maybe I click this one, and it will show you immediately in the trend chart. And to know it about the trend of this car park, which is the peak hour, which have so many space in these car parks, that you can know which time, which hour you come here, and you could get the high possibility to have the space to park your car. And also the recommendation table, you be update about with you select another car parks, and you can see if you select the car park, it will become the starting point of it, and this one will become the destination of the nearest car park. And you can see theirs will be changing if you select other car parks. For the heat map, there's you can get it as, and you can pan it, and you can find which area you are interest of it, and get to know the informations of this car park. As you can see in this time, not every car park is parking. Uh, Not every car park is for a yellow color, and this heat map can is partly show us that there's so many car parks. There is 50 or more space left in here. So if everyone is living near of these car parks, they can find the space very easy. So that is how our visualization websites work. And for the next part, my teammate will introduce about some forecasting of the data.
Okay, so in this part, I will talk about what can we do based on parking data. And as you can see, forecasting. So at first, we capture data from 6 parking lots in Macau between December 26th to December 28th, with a frequency about 1 time per 2 minutes. The data captured includes the remaining space for cars, motorcycles, electric vehicles, and other vehicle types in different parking lots at different moments in time. Considering that all parking lots are set up with car parking spaces, and the problem of parking generally occurs in the type of cars. Therefore, only the car data were statistically analyzed here. The data from 6 parking lots were first processed. Here you can see. We found that the 2nd, 11th, 20th, and 28th of these parking lots have a large amount of missing data in the limited time period, so they are not considered. After deduplicating the data of the remaining 56 parking lots, the car parking space data of these parking lots were extracted. Since the data were from 3 consecutive days, and the parking lot data would generally change in a cycle of 1 day, the 3 days data were selected separately and plotted. And here is the first day from 26 to here is 1 parking lot data of 3 days, and here the 2nd day, the 3rd day here. After the plotting, it was observed that there were 2 obvious trends in the single day data fluctuation of the parking lot. And one was the U shape like this, and this one, and this one. These parking lots have less parking spaces in the morning and has more parking space in the morning and evening, and less at noon. And the other is inverse U like this. This one and this one. This parking lot has less parking spaces in the morning and evening, and more at noon. The remaining parking spaces in 25 parking lots, including the 8th, 9th, and 10th, and in the shape of U, the remaining parking spaces in 18 parking lots, including the 3rd, the 4th, and the 5th. The remaining parking spaces in the 43rd and 47th parking lots are in the shape of W. 40, here's 44, and here 43, yeah. And in some other people's articles, it is pointed out that the parking lots around the residential area are in the shape of inverted U, and the parking lots around the work area in the shape of in the shape of U is therefore we believe that the 18 parking lots, such as the 3rd, 4th, and 5th parking lots, mainly serve the parking demand of residents in the surrounding residential areas, and the other 25 parking lots like this shape mainly mainly serve the commuting and business parking demand of the surrounding office areas. Next, I want to show you some data, some work based on the data shown by scatter plot. Okay. Here we using the data from 26 to 28 days. I calculated the time when there was the least and most parking space left in these parking lots, and plot here. The blue dots indicate the time when the least number of parking spaces and lived in different parking lots, and the red dots indicate the time when the most number of parking spaces are lifted in different parking lots. From the graph, we can find that the distribution of the list time is relatively scattered, most between 0 and 15, while the time with the most number of parking spaces is mainly concentrated in the period from 15 to 0. Further, the plot with coordinates for the time with the highest number of parking spaces is as follows. Through this figure, people can understand the time when the maximum number of parking spaces are lifted in different parking lots, and because of the obvious regularity of the change of parking spaces in these parking lots, this figure can assist residents to choose other parking lots when there are no parking spaces in the selected parking spot. And next, I use this trend, build a model to focus parking space. For the same parking lot, when the number of parking spaces at a certain moment is known, the number can be combined with the trend of parking space change on the same moment on different dates with the same trend to achieve the purpose of predicting the number of parking space in the short time period in the future. And I will show expression here. Y2 is equal y1 plus x2 minus x1, where y1 represents certain number of parking spaces, and y2 is the parking space at the moment you want to predict, and x1 is number of parking spaces at the same moment in the past, and x2 is the number of parking spaces at the same time in the past for the time you want to predict it. Okay, so it's easy to understand. And using the existing data here, I build the model. Here I use the data from 26th to 28th of December, and the trend of parking spaces is same. These days trends are same. So here I use the data from 26th and 27th days, set as x, and here x, and y is use the data of 28th. As an example, suppose the number here I will show you. Suppose the number of parking spaces in parking lot 3 we want to know, and here I know the time is 12 o'clock, and I want to know the number of parking spaces in the parking lot 2 hours later. So here we input 2, and next we got the number, and we can see now the certain parking space is 14, and after 2 hours the parking lot has 16 space. And here I want to verify my prediction. So here shows the actual number of parking spaces is also 16. So here we can see we got a good model, and by this model we can easily predict the number of parking spaces. Okay, next I want to invite my partner Bob Qinyang to show you more about forecasting.
3, 2, 1, go.
Okay, thanks for the sharing of my two other partners. In this part, I will share you another forecasting model with time series method. And then I will make a conclusion of our whole project. Also, I will show you our poster reports and the GitHub. So for the forecasting model part, we can see the left side of this slide. This is the data of 61 parking lots in Macau. As we can see, not every parking lot's data show a great shape here. So we select a few parking lots as the partner to make a prediction. At first, we try to using some traditional time series model like exponential smoothing, ARIMA, and something like that, to make a prediction. But it didn't show us acceptable results. So we are trying to make figure out the reason. So we make a decomposition of this time series. So we can see the result of this decomposition. For the trained part, it should be increasing line, right? But it didn't show us as what we think. It show a little bit seasonal, right? So we think that this is a good republic, but this is a good guidance, but it didn't fitted model. But for the seasonal part, it actually show us a good seasonal. So we want to figure out the reason or the core of this model to make improvements or optimization. So we trying to uh, we trying to um, select a better parameters of time series model. As we know that the frequency is the most important parameter of time series model. There we're trying to we are trying to using the spectrum analyze to figure out a suitable frequency of this model. As we can see, results of spectrum plots, we can see that in the first of these plots, it's reduced increasingly. Okay, it reduced quickly. Okay, and when we make a deep step, we find a clear plot of this of these points. We can see that from the first point, almost 200, come to the point of 25. We think that 25 is a suitable parameter. It's the frequency, suitable frequency of this model. So when we take place of the frequency as 25, it do really show us a good prediction. It do really show us a prediction. So as the slide showed, the prediction with time series model, this example show us the data and the prediction in this plots. We can see that this is a classic time series, with trend and seasonal, and our predictions also shows us a great trend and seasonals, right? When the nearby data reduced, the prediction also reduced. But we but in the after we find that when we trying to using this model to predict other time series, it didn't show us great results. So we think that this is because that every parking lot has their own characters or their own features. So only one good models didn't fit didn't couldn't fit to other data sets. Okay. And for the part 4, this is what I want to see is that we're trying to make a conclusion of our whole model. For this part, I want to share you 2 main topic of our project. The first is our goal. This project is coming up with our three, and me and with other 2 partners. We are trying to figure out some problems in Macau. In the first, before we select this topic, we have tried another topics like the food, the tribalism, and other topics. But we think that as the introduction said, parking is really a travel in Macau, So our goal is we are aiming to make a good use of this information of parking space in Macau. When we collecting these data sets from the official website of DSAT, is the official website of Macau, we find that this data didn't show a good visualization. It's not good for the people who want to parking in Macau, and and also I think it's not good for the government to manage these parking lots. So we're trying to use these tools of data science to make a better visualization, and also using our algorithms like traditional machine learning or time series model to make some prediction, or make some prediction to help people in Macau who want to parking more convenient. And also we did it, and finally we did it. We built a parking data board, uh, as we showed before. Also we push it on the website, and we also did the forecasting model. We also did the forecasting model of the parking situation by our models. Okay. And for the contribution, I have think a lot about our contributions, and I make three main contributions of this project. The first is that we built the real-time data dashboard of each parking space in Macau with better visualization. This is what I mentioned before. You know that for the general students or the regular students, we just collect the data and do some analyze. But with time goes by, it didn't useful in the next time. So we want to make a real time project. When we finish this project, other people can use this project to get some information from the website, and the visualization part, we thanks for the Plotly. It's really a good tools of visualizations. We can make better visualizations than the official website. For the official website, it just show us some numbers. It can't give us the information directly. So let's go into the second point. The second point contribution is that we set up the whole parking lot systems for data source to client with 3 levels in construction. This is from the prospect of the systems. We when we want to build this project, is that we want to figure out these problems, not for the homework, or not for the final project. So we find that the first we should make systems to make this data useful. So we built these systems. Our systems, and then I will in the next time I will show you the poster after a few minutes I will show you the poster. It has the construction of our whole project. You can see the three levels of our project. I believe that by doing so, our project can be improved by other engineering or other people who want to make the parking in Macau better. So I think this is significant for the people who want to build up or who want to make a contribution of the smart city, or the make some contribution for the government. So this is good for them. Okay. And for the second is that for the algorithm part, also the model part. The owning systems, owning system is not good, not enough for us to get well known on the information of the parking lots. We want to make it more convenient for people who want to parking in the next hour or next few minutes. So because of this, we should make a forecasting model to give them more information or suggestions for them to parking in Macau's parking lots. Yeah. So we forecasting the changing number of parking space by both the statistic model and the time series model. And when we doing this project, we want to make we want to try have a try with other models like machine learning, but because the limitation of the time and the technology, we didn't achieve this. But in the future, we will make it better to use more model, more strong model, or more Boston model to make this comes true. Okay. So this is our three main contribution of this project and goal. For the next, I will going to show you some materials of our this project. This is our poster made by ourselves. Our title is Parking in Macau, a real-time dashboard and forecasting for parking space. And there is some information of our three contributors. We are coming from the Faculty of Innovation and Engineering, Macau University of Science and Technology. Okay. For this module, we first introduce our problems and contribution. And also show people our goal and contributions, like what I just said. And the second is our dashboard. We just show the website page, and show some details of this page. Our tracking, or our heat map, and nearby recommendation, and the drop down selection. And for the third third part is the construction and module. This is what I just said. I want to show you is that we build these systems. Systems means that we should have more sense on software or engineering things. This plot is shows the whole project we using web crawler download this data, collect this data on our Circle, our database by SQLite. Okay, and we also did some analyze of this data. We did some forecasting, and we also transform this data into better visualizations. It's good for the clients, and our systems has three levels. The data level, technology level, and the function level. You can see that the data source from DSAT and some technology required SQLite visualization, Plotly, and so on. Okay, and this is and for the function part is this function under the of this technology. Okay, and for the last is the forecasting part. We used two different models to trying to make a forecasting of parking space in Macau. This is our results. This is our results of our prediction model, and we also show you some details and the procedure of our analyze. Okay, this is our posters. Hope you will like it. And this is our reports. You can find more details of this project in the reporters. We introduce more details of the technology and the background of these whole models. Okay, if you interested in this project, you can read these posters. Also, we put this posters in our GitHub. You can find it in our GitHub's account. Okay, parking in Macau real-time data dashboard and forecasting for parking space. So this is our whole project and some materials of our project. In the end, we believe that by our contribution of by our contribution of the of parking problems in Macau, this situation will be better. This parking situation will be better in the futures, and we also believe that data science will change our lives. Okay. So this is our whole materials. Okay. Thanks for listening. Thanks for listening our whole project. This is our project called Parking in Macau, also in Chinese, 奥博. Hope you will like it. And thanks for listening, enjoying your data science life. Thank you. This is my part. Thank you.